In order to sketch a graph of this, in this section, they encourage you to write this in a standard form. So that's what we're going to do. We're going to write this in a standard form so that we can easily find the vertex. And then actually, when this is in standard vertex form, we can more easily find the zeros, the X-intercepts. And so let's do it to it, shall we? Let's set it up. We got x squared minus x, and then we're going to put a plus blank right here. Let's put parentheses around it. And then we have a plus 5 over 4. Is that 5 over 4? Yeah, 5 over 4. And then we're going to put our minus blank right here. Remember, you got to add it and take it away. So this is going to be our new f of x. We're going to rewrite it. It's actually the same f of x, but we're just going to write it a different way. All right, so what would I add to this to make this a perfect square trinomial? So you take the middle term. What's our middle term? Uno. Okay, we take uno and we divide it by 2, and then what do you do with that? Square it. So what do you get when you do that? You get 1 over 4. So I'm going to put 1 over 4 right here. And then so what do I have to then take away because I'm adding? I have to take away 1 over 4. How come I don't have to multiply it by anything? I know, because there's no a right here. Sometimes if there's an a right here, you have to multiply the a times the 1 over 4 and then subtract that. Okay, so now we have a perfect square trinomial. So how would we write that in factored form? Well, you can factor it, or you can use our cute little trick. Because you know this is a perfect square trinomial, you can write x minus 1/2. And all you have to do is take the middle term and then divide it by 2. If you don't like that, because you're like, what? Why are you doing that? Then you're going to have to do the factoring thing. You're going to put 1/4 on top, and you're going to put -1 on the bottom. You're going to ask yourself, self, what multiplies to give me 1 over 4, and then adds to give -1. And you would say, well, self, how about -1/2 times -1/2? Because that'll give you 1/4, and then add to give you -1. And then you would factor it, and you would get x minus 1/2 and x minus 1/2. And then finally, you will get to x minus 1/2 squared. Is everybody cool? Is everybody with me? Yeah? Okay, but you guys like the shortcut better, right? Yeah. Right? Yeah, of course you do. Because you just take the middle term, then divide it by 2, and then you put it down here. I like that. I like it a lot. All right, so then we have 6 over 4, which does simplify. I'm going to write this as 1 and 1/2. All right, we good? Oh, we have to subtract. Oh, I added. Silly goose. Okay, so we got 5 minus or plus -1, and then you get 4. So that's 4 over 4, which equals, what'd you say? Yeah, you were so intelligent. Stop it. Okay, we have f of x. And now we have our vertex form. Yay! Can you guys easily see what your h and what your k are? What is the hk? This is your vertex, people. 1/2, comma, uno. All right, so this is our vertex. Not Doug. Because remember how we always think the opposite? You guys worked on shifting before. And when it says -1/2 in there, how do you change the x squared graph? What does -1/2 do? Moves the x squared graph. Now here's the x squared graph. Which direction does it move? It moves to the right. All the way over to the 1/2. And so we're going to put a dot right there. But then, what does this +1 do? It moves the function up 1. So then we would have to go up to here to 1/2, comma 1. Wow! All right, that's where the shift would happen. So our vertex is positive 1/2 and then positive 1. But what about our X-intercepts? Now, I just did a rough sketch of it. See that purple graph up there? Does that have any X-intercepts? It would have X-intercepts if it goes downward, huh? And then I would have an X-intercept right there and right there. But this graph does not go downward. You know how I know this graph doesn't go downward? The leading coefficient is positive. It is not negative. If it was, then it would go downward. But this is the way it's going to look. So we shouldn't get any X-intercepts. And so what we do to find X-intercepts, actually, we take the function, we set it equal to 0. And then you solve it. What would be the first thing you do to solve this? Okay, so you get -1 equals x minus 1/2, which, boom, an alarm should go off in your head. Why should an alarm go off in your head? Because you can't square anything to get a negative number, unless it's an imaginary number, right? Right. Okay, see, if I square root this, and I square root this, I would get plus or minus -1, which is plus or minus I. once we are in the imaginary territory, we know that we do not have any x-intercepts. I would add 1/2 to both sides, and this is what I would get. I would get our zeros are 1/2 plus or minus I, which don't exist on a real graph. That's why we don't have any x-intercepts. And so, what else can you do to make this graph a little bit more accurate? Because I don't know if we're like this or if we're a little fatter than that, like maybe like this, I don't know, or a little skinnier than that, maybe like that. What would I do? Yes, the Y-intercept. Y-intercepts are so simple to find. Why not find the Y-intercept? All right, so let's make a little table just to create a visual for you guys. If I'm looking for the Y-intercept, that means I'm plugging 0 into the X. When I plug 0 into the X, I would plug it into right here. Or I could plug it in right here. Ooh, let's plug it into this one, huh? Yeah. Because what is the Y-intercept? 5/4. Wow, that was really simple. Or you could have plugged it into here, but that's more work. You would still get 5/4. So that's 1 1/4. So there's 1 right there. So I guess we would make a 2 right here. So 1 1/4 would be right here, huh? So we have to go like really wide. So that's more accurate. So that brown kind of goldish marker line right here, that is my sketch. I found the vertex. I found that there were no x-intercepts, and so I found the y-intercept, so then I could do a rough sketch.